Good morning, good evening, good afternoon, everybody. It's February 22nd. We're having another technical roundtable discussion with the Antelope node operators. Before we get into it today, we're going to continue. I think this is our third week on the topic of special purpose nodes. We left off just starting to talk about second layer solutions. Before we get into that, we can maybe get a quick update on Antelope software status.
Yeah.
This will hand it to you, Brian, for that.
Thanks, Daniel. So yeah, this is kind of a meta update. We are closing in on our next release coming soon. So within a few weeks from now, we'll probably co-opt one of these sessions to do kind of a release overview of what's in the release. And of course, I'll make sure prior to that to sort of announce when that's happening on the relevant Telegram channels so that people can join if they don't typically join, or whatever. So you'll get a kind of a preview of what's coming soon in that session. And besides the update that update is coming, I don't really have an update, right? So.
We love announcements about announcements.
Yeah, exactly. With that, we can hop into continuing our discussion. And of course, for some reason, the computer doesn't like sharing.
You haven't given it the permission to
No,
restrain.
It does this for some reason every once in a while. Like Zoom does have permission, but like for some reason it only lets me do it sometimes. Let's try again.
Nope.
Well,
would you like me to drive, or
do you wouldn't mind, just so we don't waste time on me doing OT stuff?
So this is it's the taxonomy you wanted to share?
Yep, node types document. Yep. So we're about to head into the layer 2 space, specifically talking about history capture, history providers, and resource providers. But we had also, just before we got into that, it sort of captured that there were some still layer 1 node types that are kind of enablers for that, and that's the DeepMind Logger node and the state history node. So first, we need to sort of capture a description of what these things are and agree if they are indeed a thing. So for the DeepMind Logger node, I think I'll go to Matthew because I know he's a consumer of this. So first, Matthew, would you propose that this is indeed a sort of a special purpose that a node plays, or not?
Yes. So in our environment, one node does one type of thing, and we have this node type.
Okay.
We also have a ship node type, which is separate. Mm-hmm. I'd also say it's probably fair to say that if you do this type, it can't do much else because of the way it's spewing the data out.
Mm-hmm.
I mean, it's like if I just launched it as a regular node and didn't consume it and trim it, it was just blowing out logs because it was just like streaming out massive amounts of data.
Yeah, so presumably this is doing a lot of disk IO, specifically writes. Is that fair?
Not necessarily, because the disk IO may be on a different machine. Yeah, it's basically like, it's almost like running state history, but always having to consume it. You know what I mean? It's not even really just kind of writing it to be called at a time. It's actively spewing data out. Anyway, point is that it definitely tends to be a dedicated node.
All right. Well, so we've confirmed that. So Matthew, do you want to take a stab at kind of a description of precisely what this node's purpose is?
Oh, the purpose of the node is to send blocks to the Firehose reader component, which is going to create the Firehose data stream.
Mm-hmm. So it's sort of like write block files for consumption by.
Is it fair to say the DeepMind portion of it really is just spitting out, I think it's the one block files, right? It's spitting out
The
block.
DeepMind Logger creates whatever's happening on the blockchain to standard out. What happens after that is up to you, but the purpose is to read the standard out and then do something with it, which is relay those blocks to other components that are listening, and then write the one block files to this.
Right. The merge.
Right. So you're not just running the node just to spit out logs, right? You need to actually do something.
Right. And I guess that was the point I was kind of making, that, I mean, something needs to be consuming that standard out, whereas the other ones are really kind of a little more passive. You're just kind of collecting data, and when you ask for it, you get it. But anyway, it's a unique beast, but it's basically just spewing out raw block data.
It's an event emitter that outputs various types of events on the network as they're occurring. That includes blocks, that includes traces, it includes resource usage, it includes a whole bunch of data. Like it's the activity of the chain is getting emitted through events, basically.
At the point where Node EOS is currently processing a block.
Yeah. Yeah, it's like a live stream.
Correct. If you want data from 2 months ago, then you need to restart Node EOS from a snapshot from 2 months ago, and let it go. Right? You can't just rewind it and go forward. You get the events as Node EOS is processing.
It's like a mind reader.
First, it's like state history, where you ask, hey, I know you have all this data. Please stream it to me in whatever parameters I provide.
Yeah. And so the purpose was originally to feed diffuse, but now it's also it's the same thing that's feeding now the new version of Firehose, and which feeds substrings, which is what is kind of the new stack that's powering the Graph protocol, and all of these other blockchains are running this stack. And Antelope, one of the things we know, this is something we've been running on various things, and one of the things we really appreciate about Antelope is how this is baked right into the core Antelope software. If you want to run Firehose on Ethereum or any other chain, as far as I know, I don't know if there are any other chains that have it baked in, you have to run a fork of their node software to be able to run Firehose. So for folks, operators in Antelope, you just take the vanilla Antelope off the shelf and you're ready to run Firehose, which is pretty cool.
Yeah, I believe that is unique FML. Yeah.
So here, sort of grade me on what I've captured so far here. Like, receives blocks from configured peers, serializes blocks, traces, etc. I want to unpack, etc. But and streams them into standard out for further processing to enable layer 2 history solutions.
We might could add that it's current state. That might be the only thing is, I mean, it's serializing it at the current place where it is in the chain. You don't ever ask it.
There's no storage component.
Not at this level, correct?
Okay. Should I just leave it at current block, or is this other like traces, etc. important?
I mean, main thing was current. I mean, that was kind of that point that I was making, is we're realizing it's now. You don't want now, make now another time.
Okay. All right. Does this feel accurate then?
Good. And good days, right?
And
the thing that we're in the middle of discussing, and we're going to send out a survey on, it is a console logging, or printf statements from your contract. So diffuse, or these can get emitted in the event log to do something with. And one of the things we're wondering about is, should we have a standard way that this is configured?
I was going to mention that under state history because that's where we run into it. The and would need it.
Yeah, it's the same question, because like somebody could output a printf that's like a gigabyte, well, maybe not a gigabyte, but you know, it could be huge,
It
right?
could be a Ghostbusters logo. Yeah.
Exactly. So the question is, you know, maybe we should put a limit on this thing, and not allow that. I'm not sure what people because I don't know what are all the uses for. Why do people want to capture?
That's what I was going to say. That seemed to always kind of be the original question was, well, why are you using console logging that's kind of state, you know, per node type of thing? And it's because that's how some of the mechanisms, I think, like if you know it's going to a surge and want to be able to respond to it, I think is one of the ways some of our layer twos, you know, I mean, or it's not actually on chain, but because the service is using it, and that's also why our ship nodes are relaying API requests types of thing, is because they use it, and there was argument at one point about whether it was included or not included in some of the state history. And I think people fought for it to be included in state history because they needed to be able to stream it out, but it's a console local node type of thing. And ultimately, what EOS USA was able to find out and break, that then makes my state history different than everybody else's. It's not like my block log is identical to everybody. I can pick it up, I can move it around. There's no difference between what I have and what Matthew has in theory. My state history files, that's not true. Anything that hit my node console logging because they were using them, it made its way into state, and it tripped up Atomic Indexer a couple times actually, and I was not happy about that. But point is that we found out the hard way. Oh, it definitely makes a difference, but we also run a lot of the layer 2 solutions that tended to use it. Liquid Apps used it. I think some of the Telos EVM stuff may use it.
I was going to make a point about that. I think that there could be potential uses there with the Telos EVM.
You may know, more about some of the other uses. I just know.
So that's interesting. So this is a concept I wasn't really aware of. So it sounds like logging also sometimes serves the purpose of being kind of like a transient state or a message or a broadcast, if you will.
It's used as a poor man's event, unfortunately. And we've talked about adding true events to the Antelope protocol, but that hasn't happened. So unfortunately, people use logging as a poor man's event mechanism. For the history plugin, there is a way of running it that you get deterministic output, but that does not, I believe, include the console, which it might make sense to, maybe separate out that from the other non-deterministic things, because console output is deterministic if it's enabled. It's just not always necessarily enabled on a node. So, I mean, maybe something along those lines could be addressed.
Yeah. So you're saying basically there's two parallel deterministic state histories. There's the one with console logging enabled and the one without it enabled.
Yeah. So currently what happens is you can run the history plugin in one or two modes, one that's deterministic and one that's not. Currently the non-deterministic way of running it is the way that includes the console logging, which is why people choose to run it that way. But along with that, you get, as Michael was talking about, non-deterministic information, specifically like CPU usage, right, which is not deterministic. Now, put the billable CPU, which is deterministic, and I'm not sure if the running state history in the deterministic mode includes that or not. I don't have to look at it, but I mean, that's the distinction. So, I mean, potentially we could do something like, one thing you could do is just say, well, if you're running ship, you have to enable console logging. and then everyone would get console login and all their ship. Now, I don't know if that's anybody would like.
I think one of the early statements about this is once you do that, like we're in a situation, I have to have it on for this service to work. But if another contract goes rogue and does something stupid, my ship node gets blown up.
Like writing Ghostbusters logos to the console.
Correct. I mean,
Yeah,
ASCII art.
Yeah, unfortunately, we don't have good billing for console output. And so if you're storing that, you'd want to bill for it, some sort of either CPU or net. I mean, yeah, there's a tiny bit of CPU probably billed for it, but I mean, it's just not, well, no, it's actually not.
It was more of not even a storage problem. I mean, it crushed things, I think, was part of the problem.
Yeah,
It's killing my nodes on demand. What's this? Click.
it hits logging is slow. I mean, you can mitigate that a little bit because you can actually turn on contract console output, but not actually log it. Those are two distinct settings, which so it's a lot more like it'll wind up in your ship, but it won't actually be logged to console, which is, that's the flow part. The flow part is actually logging to console.
Oh, sorry, Kevin.
Yeah. So, I mean, there's some things that could potentially be done there. We could also, like, Shift could deterministically say, we're only going to store the first X number of characters, right? And that could be the new standard. And then that way, again, you get all the Shift to do the same thing, but you're limited to say, whatever, 256 characters or 1024. I mean, whatever for
So we did an analysis. We looked at all the blocks on EOS and find out like what's the pattern to the console logging usage. 95% are less than 5,000 characters, and I forget what the distribution is. In this order of magnitude. Well, quite steep actually. So
there's some that are over 5,000. Well, that's crazy.
if there was like 80,000 characters, which is probably
Wow,
Ghostbuster logos or something.
there's some more nice.
So yeah, I think it's worthy of a discussion about where can we just chop this, and I'll agree that where we should chop it, and then even though it's not, we really need to fix the root problem, which is have a proper event system, whatever. But until then, we all agree we're going to chop it at X amount of characters, and then that's it, and then that prevents.
I mean, I like the idea of rate limiting and also potentially putting like a contract white and blacklist on it as well. So then you only get logging output from specific contracts that you might want to specify. That doesn't make the output deterministic. But I'm wondering what the requirement for a deterministic history at that point is anyway. I mean, you've already got the blocks log, you've already got the state that can be recreated if necessary. Is there a specific reason like each node would need to have the same like deterministic state history?
So when we're talking about
not. Go ahead, man.
no, so for state history, maybe not. For Firehose blocks in the graph ecosystem, we want to enable things like multiple providers providing blocks and then you want to be able to prove that all providers have the same thing. So either you could just check some whole storage thing, or you would have to come up with an algorithm that says, well, yeah, but this guy has console logging and this one doesn't, or whatever, and then take that out, and makes it much more complicated. If we just all agreed what we store, all that complication just goes away. So I would rather do that unless that's not agreeable, and then we have to go with the other solution. So
Well, the only thing I'm thinking of is in terms of like the EVM, and this could potentially be a deprecated feature as well. But like if there's like a hard limit put on the output to the console logging, then that could potentially affect like downstream functions that rely on the log output. Like if it can only get sort of like X number of characters, then it might actually need more characters than that.
well, that's why we need to figure out what things people are using it for and how many characters they need. But 80,000 characters in a console log is not reasonable.
Right. I think you ultimately kill the a global acceptance of everybody turning on console logging if it has that open-ended exploitability. But can we find a happy medium to where, okay, is 8092 a better, you know?
Sorry, I thought you said 8,000 before. 80 better.
I mean, the position in the past has been, you know, from the core team or whoever that, you know, you shouldn't be doing this, right? I mean, when that can come up.
But yeah, people still do. So because they have no
the answer was, don't do that, as opposed to let's try to come up with a limit or, you know, do this. The answer was, no, stop. That's not what that's for. You know, use inline action instead. You know, that's what.
Can you Vince publisher?
Well, this reminds me of, like in W3C, like one of the ways that they approach things is they will not consider a feature until they see hacks being built in the wild, right? Like, so they want to see the wrong way that people are doing it, and then they'll build the quote unquote right way for people to do it. You know, so I think the fact that people are doing it is an indicator that there is something of value here for us to consider for sure.
But I mean, you can do the right thing today, right? The right thing would be to do an inline action, and that's in your trace. That's deterministic. It's there. It's billed for. It's all proper. Like that's the way it should be done. Now, yeah, we could wrap that up into a nice event, a mechanism. We'll talk about doing that. But I mean, the right way today is to use inline action.
But don't inline actions have security implications though? Like,
well, they have limits, and maybe that's the issue. You know, particularly if somebody needs 80,000 characters. Obviously, you can't do that in an inline action. But
I'll say the people that have
you could be signing a transaction that's doing things under the hood that you don't realize it's doing, right? Like, so.
I'll say that the people that have tended to do this, I mean, there's obviously a lot of people I don't know, but they are pretty smart individuals and are very in tune with what the software can do. Matter of fact, many of them were pinging you, probably Kevin and the crew years ago. So, I mean, it's not like a lot of people use history because they don't know how to properly look at their information on the chain. That's more of a, you're not doing it right and you should do it better. There's been several solutions, and even one recently developed in the last year. I mean, Telos EVM, those guys are very familiar with how things work, and they still use console output. So there's something.
It would be interesting to get feedback from those guys. Why did they choose
Ryan, do you know?
console output as opposed to an inline action? Was the limits on the inline action too onerous for what they needed to achieve, or was it simply it's cheaper to use the console outlet because you don't have to pay for it? You know, and if that's the answer, well then, no.
Which actually is an interesting point, because that's maybe part of what's at the heart of why we don't like big console log quote unquote events, right? Because nobody's paying for them, right? So,
well, they
paying for it. People on the call is paying for it as opposed to
right.
Yeah, that's the problem.
Yeah. I think that we have gone a little long on this. I do want to check a theory here to see if this is true. You know, Ryan asked the question about like deterministic state and why it matters. Is it true that if we had better sort of state history determinism, then that could have implications to sort of standardizing state history providers down the road? Does that make sense, what I'm saying? Like, because you'd have provable state, you would be able to sort of trust state history providers.
Well, yeah, I mean, if you want to have a provable state, then you want everybody to have the same, then it needs to be the same, right?
And then I think, you know, based on what something Michael said about like, I have to have the logging part of my state because otherwise this use case doesn't work. But then this other contract does logging in a way that's not good and I'm stuck with it. It seems too like there might be a case for determinism of partial state, right? Like where if you didn't capture everything, you could still have provable determinism for the part of state that you did capture. Does that seem right?
Yes, but let's fix the problem where why are we needing this?
Yeah.
I think that's really the
Yeah, and I wrote down some follow-up on sort of notes on that with some of the ideas that folks mentioned, including sort of the maybe we should have events, maybe we should have character limits, maybe we should have rate limits. Is it valuable to have configurability on which logs we capture, and what does that do to state determinism, inline actions as an alternative, etc.
one of the
Should it be built? Is that a thing?
Yeah, should be built. Yeah, one of the things I was thinking of is like maybe I could keep console logging for, X number of blocks and then throw it out. So if I was trying to build like a block explorer, for example, I'll keep the last, 10,000 blocks or something, because that's what it's supposed to be used for debugging, right? And then after that, it gets thrown out because, well, it's one for debugging.
I think that some processes were written for it to be, an event that they could still see even if going back, like liquid.
Yeah, so those processes should be fixed.
Yeah.
That's what I'm arguing.
Yeah,
I mean, figure out what they're doing, figure out what's missing the software, change the software to do it, get those processes to change, and then change the console logging output accordingly.
So I think
Modes, when this all started, and that we ran it in, console logging would have only been in developer mode and never intended to be run on any production system anywhere. It was only ever intended for contract creators to add debug logging to their contract so that they could debug it while they're developing the contract. Once it was deployed, it was never intended to actually be live. Unfortunately, we are far down this road of it being used for other purposes.
Yeah, for what it's worth, I'd like to think that most of the contracts and applications that are going to be built on EOS actually have not been built yet, and therefore figuring out the right way is still worthwhile. All right, so I think we should cut that part of the conversation off for now and move on to the state history node. It was a valuable discussion because there's a whole aspect of state that I wasn't aware of. So thank you.
Well, and that does somewhat tie directly, I think, to a lot of these feeder nodes, API too.
All right, so state history node. I think we all kind of know what this is, but I'd still love for somebody to take a stab at describing it. I'll call on Kevin. What's
Probably the best.
State history node is just simply a node running the state history plugin.
Profound. I believe it takes all, similar like DeepMind, all the block traces, all of that, and stores it in an additional log file. So you've got your block logs, and you've got all these massive state history logs, terabytes. There's 4 files, 2 indexes that are neat, and 2 files that just destroyed. terabytes of contiguous, fragile data.
Yeah, and this always writes to disk, but not necessarily on the same device, right?
I missed the first part. Say that again.
So this state file is always written to disk, but not necessarily on the same
State history, just to differentiate it from actual state.
Yeah,
Because the state is its own DB. But yeah, it's written, it normally can have its own location, although it can't really be split up other than, oh, you got 11 terabytes of files? Pick a path to put it on. And it's not like sliceable, I mean, it is trimmable, but you don't, like the block log, you don't have any of that previous history. So it's one of the main mechanisms. I don't want to say the only mechanism because I know Aaron does magic with trace API, but state history is what, in our opinion, most people use to latch onto a node with a WebSocket and be notified of either current events going forward or batch going backwards. Think of me indexing the whole chain of the history into Hyperion. It goes through the state history and says, give me 1, 2, 3, well, blocks 1,000, 2,000, whatever.
Is a state history node always used for providing some external service, or is it just used for internal purposes sometimes?
It's normally feeding something. You really have to you have to consume it. You have to deserialize it. You have to, connect to it.
Are people using this as a internal only backup or sometimes, or is it always feeding something that's being exposed as a public service?
It's just internally, right? I mean, you could run your own Hyperion for your own purposes.
Yeah, most of the time you have it feeding something, which typically is like on an internal, the public doesn't directly ingest from the WebSocket. It can. We do offer it publicly to help bridge some gaps. The reason it's suggested you don't, loosely, is, as I understand, it's a fire hose of data. You can ultimately crush the thing by just simply asking for a crap load of information. So it's more just protected to keep people from just sucking on it so hard.
Mm-hmm. I might be opening Pandora's box of what's the word, of controversy, but it sure sounds like these two things are redundant to one another. Is that fair?
They're similar. They're similar.
This is why I was talking about a feature matrix in chat, because state history is like the monstrosity that does all of it. Whereas the trace API just records traces. The DeepMind Logger just streams the information but doesn't record it. And state history records it, it streams it, and it also stores it in a way that it can do diffs between certain points in time. So it does do what the others do, and that is why it is so heavy, is because it does everything.
By that man of being well done.
State history misses information because it does it on a per block basis, whereas the DeepMind Logger does it on a transaction basis. You can get the state between each transaction there, and that's not captured in state history.
It feeds them down to the action level, right?
Yeah, down the action. Yeah. Fair. And so the DeepMind Logger is, if you need the details, then you need the DeepMind Logger.
Yeah, granular.
Sufficient.
Yeah, I don't think there's anything that the state history provides that the DeepMind Logger doesn't provide.
DeepMind is also maybe feeding. Is that how you're hitting your failed transactions? I know you guys do something with failed.
No, DeepMind Logger is only looking at whatever makes it into a block.
So it seems to me like there's also a worthy future discussion to take a machete to the to the question of I don't know. It feels like it's not ideal to be building and supporting two solutions that effectively do the same thing. And we should determine best attributes of each. Sorry, 3. Yeah. The best attributes of each, and then see if there's a way to, with one solution, get all of the benefits. Because I think that from an E&F perspective, having to build and maintain less is good. From a community perspective, if there's more, value add software built around a single, solution, that's probably better too, right? Than having sort of different things.
I could probably re-engineer ship on top of firewalls. Probably build.
Yeah. I think all 3 serve a unique purpose. It's just some of them serve multiple purposes. And if we could trim them down so that way they are less each one of them is less, then each one could serve their specific purpose better. Like ship could be more lightweight if it didn't handle the same things that Trace and DeepMind did. And like that's the other two kind of do the one thing already.
Right. So it's kind of like if all three of these could become one type of feeder node, and then like what they're feeding becomes separate layer 2 things or something like that, right?
Yeah, I would not say merge them though, because
I was about to say, he's saying keep them separate.
but just
But
focus
keep
them down.
separate. Yeah, focus on what they need to do and not try to do everything.
Like state is
Remove the bloat from the state is the one that's the bloated one, right? So
I see. So
you're showing how DeepMind is very specialized. So is Trace. State is trying to do everything all at once, plus some other stuff. So
That's
we're each.
we keep all three's purposes, but we remove features from each so that their purposes are more distinct and clear. Is that?
yeah. And
And
this
make
is why
them
everybody
together.
This is why everybody uses state history, is because it does everything, and it's the elephant that does everything. It's like if they each did their specific thing, they do one thing and they do it well, then
Yeah.
people could run multiples of them. And if you enable all three, then you effectively have what state history does today.
Correct. And I don't know, I've never tried.
But if you merge them all, then you're forced to run an elephant when maybe you don't want an elephant. You just
Correct.
mouse.
So go from a like a Venn diagram where some stuff is overlapping to more like a pie chart where everything's just all segments.
Yeah, right.
Yeah.
I'm going to just take a note on that as a follow-up. So
I do like Aaron's idea of it being a matrix. I mean, that's how it kind of is in my head. Is
We kind of
They
do
all
that
kind
in
of-
API Plus Blue Paper. There's a feature matrix in there, and it also includes Chronicles and Robo and Hyperion, but you could really easily make a feature matrix between those three and what they do, and you'll see the overlap.
all right. That was a very robust and rich conversation with some potential future direction.
It's amazing how discussing the node types, generates all these other issues.
Yeah.
well, it's the reason we run so many different nodes. I mean, it's just, well, why do I have that one? Because of this. Why do I have a DeepMind and a state history? Luckily, I don't run trace history or trace ATL.
Yet.
Trace is easy.
All right, let's finally dip our toes into layer 2 with little time left on this call. History capture service. Is this indeed a type of layer 2 thing?
I guess, I mean, it's really, you're talking about processing it. Are you just dealing with the data and using it, or are you like storing it?
Conceptually, I think what I'm talking about is taking some output from one of these feeder types and processing it into some index data format, right?
Yeah, I don't know if there's any difference because there's such a variation on the back end. You can capture it, you can store it, you could just process it, you could, I mean, it's the fire hose, do whatever the hell you want to with it. In state history, it's pretty broad.
There are a lot of solutions in this category, and they are the ones that just take those feeds from the other solutions and record them somehow or process them. They don't necessarily need to record.
Correct. They may put them in their database. They may, use them just to trigger other actions. They may, I mean, it was the ability to receive events from the chain, and it's a massive web of what it can feed. Those are all those layer 2 solutions.
In a publisher subscriber situation, the three that we just finished talking about are the publishers of information, and these are the subscribers to that information.
Right.
Which could have for old data, could have for current data,
Yeah, and I think I think this is purposefully general maybe because I could imagine you processing just history related to your own contract. I could imagine you, having a general purpose history API. I could imagine
listening for events
a pub sub hubbub, interface for these things.
And there's a lot of apps that don't even store any of the data. They really just kind of listen for what they want. Then they have to store a little bit of data to handle fork, logic and all of that. Because that's another thing, you're talking about a publisher. It's like, here's everything I got. If it forks, ultimately the consumer has to go, oh shit, I already seen that block number. Let me take a step back and handle it. You know what I mean?
Yeah, that's where a lot of the solutions, a lot of the history capture services struggle is with fork resolution, because it's kind of up to them to do fork resolution.
Correct.
A lot of the time, at least.
That's an issue on state history, I assume. Is that applied to the other two as well? More as the publisher. It's just sending out, here's a block, even though it already sent out a block, that it now has to go back and be like, whoa, everybody else says no. I would assume it's a real-time data feed, right?
The DeepMind Logger sends enough information that, you can reverse things.
But the merger ultimately does it, right? It's the consumer that handles the fork still, correct?
It's still the consumer that has to handle the fork.
Yeah. It's the same with the Trace API as well. It's a common feature.
So yeah, all three of them. That's why, just to kind of put that in there as another quirk, it's serialized and you have to have fork resolution. Those are the two things I think that most developers have been like, crap. Okay.
Yeah. So does this capture it, or is it still a little weak? Processes the output of a feeder node type into special purpose formats for a variety of purposes.
But it might not be history.
Right.
Because it can be real time.
Yeah. So what is this actually then? It's not a history.
Yeah, you type, it could be used for history, or it could just, if you
event notifier.
that's like Kafka or something.
In that aspect, the way I kind of see it is that term, that event notifier. They don't care about what happened more than a couple blocks ago. All they care about is figuring out what they need to figure out at the current time and moving on past it. That's an event notifier. It's just, that's the only WebSocket. Or what people do is constantly smash the API and say, did that block have it? Did that block have it? Did that block have it?
Get block.
Correct. That's what you don't want a WebSocket, you want a REST query or something. That's the way they smash through it. But we've tended to say, hey, look, you really need to have a WebSocket to subscribe to it. Oh, well, it's not, not only do you have to use a WebSocket, but now you got to also process it and then get the data you want out of it.
Yeah. So this is like
an event capture.
Yeah.
Right. I like that term. Whoever said that first.
Yep. Okay.
And then history provider at many different levels. All the data, just my data, just a subset of data, whatever. But
just the events, the historical events.
Correct.
And now you're to this infinite number of solutions possible.
Yeah. Which I think is the power of separating these, right? Because you could have arbitrarily arbitrary use cases supported by this, right? Okay. 2 minutes left. Can we cover history provider or no?
I don't know how deep you want to go into it.
Yeah,
basically, they're just reading all the data and storing it in their respective formats to be able to provide API and queryability.
Yeah. It's the API layer. Basically, it uses an event capture service to store the data and then services API requests.
Right.
For clients to request. Is it state history? Yeah, I guess so.
Chain data.
Whatever.
Chain data.
Historical data. Historical events, if we want to follow that path.
Right. Like a simple history thing could just be, give me the list of all the accounts on EOS.
Yeah, and this can be provided in any format, right? Like this could be a REST API, a GraphQL API. It could be a,
database, MySQL.
right.
Like whatever.
Got all of those.
And we have all of them. We probably don't have all of them, but we have a lot.
Well, yeah, all that you have to grow. But yes, and that's why I say is that this could be an exhaustive list, because that state history, at least for the most part, has been what the developers have kind of latched on to and said, okay, if I don't need to beat the crap out of history solutions or the API smashing each block, I need an event notifier, either of historical events or current. And it's all over the place beyond that.
All right. Good discussion today. We are at 10 o'clock. I'm going to hand it back over to Daniel.
All right. Thank you, Brian. So, yeah, agree. Great discussion. I suppose we still have more to carry on next week. So we'll do that. I'll share the notes and the recording in the chat as soon as it's available. So have a great day and get your Pomelo applications in. Today's Pomelo Season 5 kickoff day. If you're looking to raise some funds, good opportunity there for you. So thanks, everybody. Have a great day.
What date?
Thanks, everyone. Thanks, Daniel.